So when we are doing radical operations, we have to think of operations in general, kind of like just combining like terms, how we did our polynomial operations. But we also have to still simplify our radicals. So it's like two different things. We can only combine, if we're adding or subtracting, like radicals, if the index is the same and they have the same radical. So the same number underneath and the same, like both square root, both cube root, something like that. So in this example, right now we cannot combine either. They are both square roots, but we have to simplify the square root of 20. I'm just going to focus on perfect squares for this and cubes later. What's the highest perfect square that goes into 20? Think of your factors of 20. 4. 4 would work. 4 and what? 5. So I know the square root of 4 is 2. So we have negative 4 times the square root of 5 minus 2 times the square root of 5. Now we have like radicals, or we could combine our radicals because they are the same index and the same radicand. And when we do this, we treat the whatever's underneath the radical as like when you're combining like terms as your x. You don't change it, you just leave it, you just combine whatever's on the outside. So this would be negative 6 the square root of 5. All of these can also be checked in your calculator. I'll do that for this one. What was that minus? Okay, and then our final answer was negative 6. So even if you're doing your operations, you can still check it in your calculator and Desmos. Subtraction and adding work the same way. So number 1, 6 cannot be simplified because when you break it down, pairs wouldn't come out. So you would just add or subtract this. So your final answer would be 1 times the square root of 6, or you could just say root 6. What about number 2? Add the 2, yep. Yes. Okay, let's do some where we have to simplify. I'll let you guys choose between 3 through 8. Which of those do you want to see if you go over and have questions about? Sure. Any others on that page? Okay, we have to simplify both of these. So let's find the highest perfect square that goes into 160. So we can divide 160 by. So make sure you're dividing your perfect squares. everyone should be on their calculator dividing 160 by 1, by 4, by 9, 16, 55. Say it again. Those are factors, but they're not, neither of those are perfect squares. 60 and 10. We know the square root of 16 is 4. 10, if we broke that down, it would just be 5 and 2, so that can't be simplified more. Find the highest perfect square that goes into 90. 9 and 10. So then we could multiply the negative 4 and 4 and the negative 2 and 3 to get negative 16 root 10 minus 6 root 10. And then because we now have like radicals, like index, like radicands, whatever, we can combine this and that would be what? Say that again.
Negative 22.
So if this was, let's say this was like 11, you just do that. We'll see something like that. So like with number 9, we have 2 that have the same radicand, but 1 that's completely different. So we can combine these 2, but this one will have to stay the same. And you would just leave that like that. We can't simplify it anymore. We can't combine like terms. We can't move these underneath the same radical. You just leave it like that. So then what would 10 be? Now look at 11 through 16. Those are similar, but a lot of those you have to simplify. Which of those you want to see do go over how questions about? 15, 14. Any others? The more things you have, the more numbers you need to keep track of, make sure you don't lose them. Can 6 be simplified? No, so we're going to leave that alone. But 150 can. Find the highest perfect square that goes into 150. That's for 54, but what about for 150? Neither of those are perfect squares.
It's 25 and 6.
So then it looks like after we multiply, we're going to be able to simplify all 3 of these because they are the same radicand. We have 10 root 6 plus, what's 18 times 5? 90 root 6 minus 12 root 6. And then we're going to add 10 and 90, so 100, subtract 12. What would our final answer be?
No.
Both?
I saw that.
Okay. 10 plus 90 minus 12.
80.
80 exactly?
88.
Okay. So with a lot of these, you might get bigger numbers in front that's multiplying, and that's okay. Finally, you figured out the answer. Are there any others we want to see you go over through 16, or any other questions we have on adding and subtracting radicals? We're going to do we'll do this perimeter problem, and then we'll move on to multiplying radicals. So to find the perimeter, I do what with these? Add them. So it would be 2 root 72 plus 8 root 18 plus 16 root 2, not necessarily in that order, just add them all up. 72, the highest perfect square we could break that down into is 9 and 8. And then what about 18? 9 and 2. And both would be a 3. We have 2 times 3 times the square root of 8 plus 8 times 3 times the square root of 2 plus 16 times the square root of 2. And then multiply. And 9 and 8 wasn't the highest because we could break 8 down. I'm going to backtrack that. Find something higher than 9 and 8. So if I had stuck with 9 and 8, I know that's 3,
36 and 10.
but this I'd have to break down because it can be simplified more. But 36 and 2 would work. So you could do that, but then you just have more, and you don't have a whole lot of space, and you already have so many numbers. So we have 12 root 2 plus 24 root 2 plus 16 root 2. Add all three of those together, what would your final answer be? I'm just going to put this in the calculator just so we can double check it, especially with your application problems like this, or when you have a lot going on, just to make sure you didn't lose any numbers. I would double check in the calculator. So we have 2 root 72. Plus 18. What was that? Actually, I think it was a square root. That's 8 and a square root. What was the last one? Okay, and then our final answer was 52. And we got the same. So please double check your answers in your calculator when you get questions like this on the SLO. Go on to multiply. Now the rules for adding and subtracting and multiplying are different as they are with polynomial operations and combining my terms and things like that. So the numbers outside of the radicals, you multiply those together. the numbers inside, you can multiply underneath the radical, and if you can simplify that, do that. So for this one, just like our x's, our exponents, there's an invisible 1 here if you don't see anything. So I would multiply 1 and -3, and I would multiply 8 and 2 underneath the radical. And then if I could simplify it underneath the radical, do that. So sometimes you get really nice things like this, where it's a perfect square. Sometimes that's not the case. So then what would number 2 be? Negative root 6, or negative 1 root 6. Multiply the outsides together and the insides together. So why did you multiply negative 1 and 6? You're multiplying the outside numbers together, which is 1 and negative 1, and the inside numbers together. You don't combine those. 3, and then we'll get into some variables. Our outside number would be negative 35. Our inside number would be
120.
Can we simplify that? Yes. Find the highest perfect square that goes into that. Only one that really works. Those aren't perfect squares. 4 and 30. And that looks wrong because 30 is so high, but off to the side, I'm going to break this down. Give me 2 factors of 30. And if I were to break down 6, we have 3 and 2. None of that is a pair. 30 cannot be broken down. So when you see 30 or 30, that's it. Leave it. Just like 6 and 10 and some of your others. Okay, so multiply negative 35 and 2, and what's our final answer? Negative 70 root 30. Always double check to make sure the whatever's underneath the radical can't be broken down more. Because sometimes it can, but if you get 30, it cannot be. Alright, in number 5, we now have variables being added to the mix. Same rules, multiply the outsides together, the insides together, but now you also have to incorporate your exponent rules for multiplying by basis. So on the outside, we have 4. On the inside, multiply the numbers first. What would that be? 36. And then into the 30. We're adding the exponents. So now we are simplifying with our numbers and variables. Well, this is just 6. And 2 goes into 3 how many times? Once. With how much left over? 1. So that would be 24n times the square root of n. Any questions on that? Okay, let's try 7. On the outside we have 2. On the inside, what would that be? 45 W to the 7. So then we have to break down the 45. What is the highest perfect square that goes into that? 9 and 5. And 2 goes into 7 how many times? Correct, so that's going to stay the same. But minus 3. So how much left over? 1. So we have 2 times 3 times W to the 3rd times the square root of 5W. So that our final answer would be 6W to the 3rd times the square root of 5W. Remember that you can check the numbers piece, so you could put 2 times the square root of 15 times the square root of 3 in the calculator, and then just 6 times the square root of 5 to see if the decimals are the same. But in Desmos, you can put in the variables to see if they're the same. Now we're going to mix it up and do both, adding, subtracting, and multiplying all in the same thing, because you might get something like that. So number 9. You have to make sure that you are watching out for your order of operations. Multiply first, then add or subtract. So we would do this part first. What would this part become? 30 times the square root of 20. I'm just going to rewrite minus 6 root 5, so don't lose anything. Is this a multiplication? Okay. Break down the square root of 20. Highest perfect square would be 5 and 4. So we have 30 times 2 root 5 minus 6 root 5. Or 60 root 5 minus 6 root 5. And then, can we combine these? Yes. What would that answer be? 54 root 5. So a lot of the times when you see multiplying, adding, and subtracting all together, you should be able to combine them at the end. Not all the time, though. It depends on the problem. Do we want to see 10 before we go on to the next page? Yes. What would we do first there? Multiply what? Yes, and then I'm just going to bring this part down. What would this become? Okay, let's break that down. That's the highest perfect square that goes into 12. I'm just going to keep bringing down this piece in front. Highest perfect square that goes into 12. 4 and 3. Excuse me. 2 goes into 6 how many times? 3. So that'd be x to the 3rd. So we have 7x cubed times the square root of 6 plus 2x cubed times the square root of 3. Can I combine them?
So 2 multiplied to 12 and 2.
Oh, yes, that was supposed to be 20. My bad. Okay. Restart. That was my math. She said 24, and I said over 12. Anyway. So what would the highest perfect square of 24 be? 4 and 6. So this would still be 2, but this would not be 6. Okay, now can we combine them? Yeah. Yes. How I did it before, we could not have combined those. So what would our final answer be? 9x
To the third.
9x cubed is square root of 6. Your exponents don't change, your root doesn't change because you're just combining like terms. So your exponent polynomial operations and your radical operations have not combined. So you need to be keeping both in mind. You don't do anything to the exponents, you just add the coefficients. Have any questions there? Can you put your phone off? Okay. The last type of multiplying you might see is something like this, where we now have to distribute the radicals. So we'll do this example and then we'll do this example. Here we're going to distribute it like you would normally. Whatever, if this is not underneath the radical, that's going to go out front. So you would not multiply those two numbers together, you would put it out front of the radical. But because these two are underneath, you are going to multiply that. And then if you can simplify, do that. So 48, we know we can simplify to what? What's the highest perfect square that goes into 48?
16 and 3.
16 and 3. So this would be 4 root 3. Can we combine these?
Yes.
No. They're not like radicals. They don't have the same radicand. That is your final answer. Questions on how we use the distributive property with just one? The FOIL works the same way as your regular polynomials, binomials. You could do the box method here. You could just distribute here. I'm just going to distribute. If you just want to rewrite it into box method, that's fine. So we're going to do each piece. The first, the outer. So we'll do those two first. So 4 times 2, 8. 4 times negative root 3. Negative 4 root 3. The 4 has to stay on the outside because it's not underneath the radical. The 3 stays inside. And then root 3 times 2. 2 plus 2 root 3. And then root 3 times negative root 3. Multiply. Negative root 9. Okay. So then we're going to simplify the square root of 9 and combine like that. So let's do that first. 8. I'll leave this. You could combine this now, but I'm just going to leave it. And then we have 2 numbers we can combine and 2 radical expressions we can combine. So 8 minus 3. And then this would become what? Negative 2 root 3. So when you leave this, you can write it like this, or you can switch it around. This way is probably more common. That way you don't accidentally put this number underneath the radical, but either or is fine. Do you have any questions there? other examples you want to see do go over in 11 through 18? Yes. Which of those do we want to see do go over? Which one? 17. Are there any others we want to see do go over and have questions about? Okay. So starting with 12, it's the same as what we just did. I should say it's similar to what we just did, but instead of just having a root, it has a number in front, a coefficient, and a root. So we're going to multiply both. So this entire thing gets multiplied to this. However, only the coefficients get multiplied together here. And then we're going to do that same thing and multiply that whole thing to this. And we have a coefficient and a root, so both things get multiplied. And then can we simplify either of these?
Yeah.
Which one? 20. So let's find highest perfect square that goes into 20. 4 and 5. We have 15 root 10 plus 12 times 2 root 5. So 15 root 10 plus 24 root 5. Can we combine these? They're not like radicals. So that would be our final answer. Questions on that one? We'll do 17 and then be done for today. $17 is using the FOIL method. So we're going to take this first term, multiply it to this one. Outside pieces go together, inside pieces go together. What would that first term be?
30.
9, okay. Then the second term, just the outside coefficients. So 6 times negative 4. Negative 24, and then the root 3 doesn't disappear, so you just put that next to it.
Minus 10 to the root 3.
And then of those, we can simplify the root of 9 and combine the middle two. We can do that simultaneously. So if I combine these two, what would that be? Negative 34, root 3. And then if I combine my constants, what would our final answer be? We're adding here, so 98. Check these in your calculator also. I am having difficulty with the calculator, so I'm going to let you guys do that. But if you put all of that in, you should get the same decimals. So for, you have a little bit of time, but you have about 10, 11 minutes. If you want to keep practicing in this, work on Delta Math. This Delta Math is due next week, but you guys do have simplifying radicals due tomorrow and rational exponents that is also due tomorrow, as well as your test snap that's due Monday and your JLabs that you get slowly appraising.